Hello class, today we're going to be continuing on chapter 12. Previously we looked at arrays and today we're going to be looking at array lists. Now you remember that with arrays, one of the restrictions of arrays was that once you created an array, you specified the size of that array, and once it got all filled up with entries, you could not make it bigger if you wanted to. The only way was by making a brand new array of a bigger size. Now with ArrayList, on the other hand, it's a type of class in the Java utils that has similar properties to arrays in terms of it being kind of a contiguous piece of memory that has a variety of different elements in it for quick access. But the added thing about ArrayList is that when you want to make it bigger, you can make it bigger, and it will grow according to your needs. So it is underlying an array, but it's an array that can grow as needed. Now, another restriction about ArrayList are that it can only hold objects. Now, you know, with arrays, we could hold both primitive data types as well as objects, but ArrayList are limited in that they can only hold objects, and we'll talk about kind of the workaround that there is to hold things like ints or floats or other sorts of primitive data types. Now, when you make an array list, you're actually reserving a block of memory in the computer, and it has a certain capacity, an initial capacity that is created for you. That word capacity tells you the size of the current allocation. Now there's another kind of notion, vocabulary word of size. This is the actual size of the list that is actually valid. We might have only added 3 elements into the array list. So when we first make an array list, you can think of it as being empty. And then we start adding pieces one at a time into it, and that will increase the size. And at some point the size will be equal to the capacity, and when we add yet another element, Java will then increase the capacity to a larger amount automatically for us. So when we declare an array list, we need to define the type of object that it holds, and it could, so we could have an array list of strings or an array list of integers, and this is the kind of the syntax for it with this less than, greater than sign right here. We put inside of that the type of object that we want the array list to contain. And so then when we construct it, we say, I want a new array list of this particular type, and we have the parentheses here to indicate we want to call the constructor. Now in Java docs, you'll see this notation a lot where you see this E here between the brackets here. And what this means, E stands for element. It's a generic parameter that describes that this array list holds some sort of object, and this E can be anything from a integer wrapper class to a string to other types of objects that might be defined. Now here are the different constructors. The no argument constructor will automatically create a array list with a capacity of 10. You can change that if you want. You could put a different number in here if you want to, for example, want to initialize a piece of memory of size 100. So if you know that your array list is going to be roughly a size of 100, that's what you would normally do instead of just allowing Java to create the initial one with a size of 10 and then having to grow it on later on. Here are some methods, just a subset. These are the ones probably that you will find useful. Size, this returns the size of your current array list. Again, it's not the capacity, but it's the size. It indicates how many valid elements are in the array list. This is analogous to the array.length. Remember with arrays, this dot length is a field. In ArrayList, there is no .length, but instead there's a method called size that returns an integer. But they're the same kind of concept idea. There's a Boolean is empty method, which will tell you whether the array list is empty, i.e. the size is equal to 0. You can add objects to the end of the array list. You could add objects to the middle of the array list, and every subsequent item will be shifted over. You can get or you can set any item in your array list at any specified position. You can remove an element in the array list at a certain position that's indicated by the parameter, and in this case all the other items will be kind of shifted over it. You could find out if an object is within the array list, and you could even find the index of the first one that matches. It's very similar again to arrays. So I would say that these here are kind of the different ones, especially the adding and removing, that you just didn't have an analogous kind of feature to add or remove elements in an array. So here's an example. We will first make an array list, and it will have a size of 10, and I'm not going to count it out 10, but again, the very initial no argument constructor call creates an array of size 10, and it's empty, there's nothing in it. Then we add the word Ben to it, so we have Ben. Then we add the word cat to it, and when we add, it appends it to the end. And in this case, we're adding to at position 0. So what we do here is cat will get shifted down, Ben will get shifted down, and then Amy will get put into position 0. And if I were to remove an element, say I removed item 1, if I remove Ben, then cat would then just get shifted up. Okay, some details. What happens when we keep on adding and we've reached the capacity of our array list? Suppose we've made an initial array list of 10, we've added 10 items to it, and we now add an 11th item. What happens? What happens is that Java, kind of under the hood and invisible to the programmer, it will automatically reserve or allocate a brand new array that is double the size and capacity. And what it will then do after it has allocated that array, it will then take all the elements and copy it over into the newly created array. So there is this kind of work that has to happen underneath the hood where Java has to A, allocate some new memory, and B, and this is where more of the work comes in, copy all the entries from the smaller array into the bigger array, so that now this new piece here, this is our array list now, where we can add new entries onto it afterwards. Now, the index I that we use to either get or set items within the array list, they have to be valid. And by valid, I mean the value of I would have to be somewhere pointing to one of these elements here. I cannot point to one of these as yet unused elements. They can only point to things within the size. So currently, size will say return, say we have 11 elements in here, size returns 11. That means I can be anything from 0 to 10. If I were 11 or beyond, it's too big and we'll get an index out of bounds exception. Very similar to arrays. Now, I mentioned earlier that while arrays can hold primitive data, array lists cannot technically hold primitive data. But the workaround is this. If I want to put an int inside an array list, what I do is I put it into a wrapper class, the integer wrapper class that contains an int. If I want to put a double into my array list in a similar way, this double will get automatically put into a double wrapper class object, which can then be put into the array list. Now, Java conveniently handles all the conversion from the int to the integer or the double to the capital D double object for us. That's called autoboxing and auto-unboxing. And I'll demonstrate that or describe it right here. So in this case here, we have an array list of integers. And I want to add to it this value 17, this integer. It's an int. It's primitive data. But what Java will do is it will automatically take the input, which is an integer, and it'll automatically put it into or create this integer object that contains the int 17 for us. So this is the automatic autoboxing. It also does the reverse automatically. When we call the get method here to get the item at position 0, it will return an integer object. But I could assign that safely to a primitive data int, because Java will auto unbox it and it'll take the integer that had the value 17 in it and it'll kind of strip it out and apply it to this count variable, which is merely primitive data. Now, some pitfalls, or one major pitfall. Whenever you use the remove, you need to be careful. If you're iterating through an array list and you're removing things, or even if you're adding things, you have to be kind of careful about your index that you're using to kind of iterate through your array. So suppose I had this array here, and suppose I have the word like, I have the word like again, and I have the word be in there. And initially my I variable points to the first element, and I'm just going to iterate through there, and if the item is equal to like, I'm going to remove it, otherwise I'll increment my pointer. So in this case here, A is not like, and so I increment my pointer, and it now points to the next item. Now in this case, like matches, so I'm going to remove it, and when I delete this, what happens, and this is where we have to be careful, is that all these other elements get shifted. And so in my code over here, it does the right thing. It does not increment the I variable, this position variable. It keeps it pointed to the same thing so that we loop back up here again, and then again we check the same entry to see if it equals like, and it does, so we delete this word as well. And then we move up this element, which happens automatically with this remove, and then again we don't adjust the I counter, we loop yet again one more time, we check this yet again, and we find out that B is not the same as like, and so then at that point we bump up our pointer to point to this next element, and now we're all done because I is beyond the size of our array list. And so this properly removed both of the likes from our list. But now look at this other case here. If we kind of had naively done it with a for loop, and let me just use similar colors, A, like, and B, and suppose I have my I variable pointing to this first element here. Suppose I naively just did this simple for loop which just iterates I every single time. So I does not, so in this case I points to A, it does not match to the word, we bump up to the next value, position number. I now then points to this word, and like matches, so now we remove it right here. So when we remove it, Java will take this away, but then it will also at the same time shift all these elements up. Now in our for loop, we have I incrementing, and so if we increment I is now going to point to this next element here. B is not equal to like, and then we're going to increment it one more time, and then we are quote unquote done. But the problem is we kind of didn't do it right. The like here has not been removed, and it's because we incremented I every single time, even though we removed this. So the proper thing to do, if we wanted to use a for loop, we just don't want to put this I++ where it is, but instead we want to do something like this. Just basically like we did over in the while loop case over here. We want to control the incrementing very carefully, incrementing only when we do not remove the element. Okay, now in Java there's this other kind of way of iterating through arrays and ArrayList. It's called a for each loop, and it's a very convenient way of iterating. So I'm going to show examples of both arrays and ArrayLists. So right now we have an array of integers, and this is the name of it, scores. And if I want to iterate through every single element in this array, this is the syntax for it. And you notice I don't have an index here. I don't have an index variable. What I'm doing here is I'm just saying for every integer s in this array scores, take them one by one, assign the first array element to s, then the next array element to s, then the next array element to s, over and over and over again. If you have taken Python, you can kind of think of the colon as the word in. So in Python, we had something like for s in scores or something like that, as a way of iterating through a list of things. So very, very similar. This is the analogous C code. If we wanted to, or sorry, not C code, Java code. If we wanted to use an index I, we use the index here as a way of accessing that particular element within the array. So this is another example with ArrayList, exactly the same thing. Again, it's an indexless way of accessing all the elements within the array list. Same exact syntax, same exact concept. Instead, with an array list, we use the get method instead of just the brackets for arrays. Now, warning. When you are using the for each loop, you are not allowed, just not allowed at all, to use the add or remove element method. If you do, when you try running it in Java, you're actually going to get an error. So anyway, just don't do it. And you see earlier kind of the problems of doing it. And so Java just doesn't allow you to do it so that you probably protect yourself from weird situations that you were not anticipating. Okay, we're going to end this lesson by doing a little example of inserting a value into an already sorted array. So given an array or array list that has been sorted, how can I stick a number in the proper place, preserving the order? So let's look at this example. My array is down at bottom, 1, 1, 2, 3, 8, 13, and I want to stick the number 5 into the proper place. So the way I think about it is this. I'm going to start from the very far right side, one beyond the last element, and I'm going to ask myself, is this element 13 bigger than 5? If 13 is bigger than 5, 5 should not go here. And what I'm going to do is I'm going to take the 13 and move it over to the other slot. Then potentially the 5 can go here. So I'm going to ask myself, is this next item 8, is it bigger than the 5? If it is bigger than the 5, then I shouldn't put the 5 here. So instead I'm going to put the 8 here, move it over, And then one last time I'm going to ask, okay, for this particular slot now that's empty, is the 3 bigger than the 5? 3 is not bigger than the 5, so I found the kind of home for the value 5, and I put it in its proper place. So this can be coded up, and this is kind of the way it works. So let me draw this out. So 1, 1, 2, 3, 8, 13. Okay? And I want to stick in the value 5. And I'm going to consider putting it right in this place right here. So in this case here, we have our array. This is our array here. This is our value 5. And our count is going to be this value right here. And so then we're going to initialize another variable, k, and it's going to have 1 less than the count. And so I'll have k point right there. And so what it does is it says, okay, is the element at k greater than the value? If it is, in this case 13 is bigger than 5, so then what we want to do is we want to shift the 13 over, and that's what this line here does. It moves the 13 to the next slot. And actually, technically, the 13 still sits there. It's not like we removed it, but it just got copied over here. Now we decrement k, and so I'm going to decrement k by moving it over. Now we go back here to the while loop and we say, okay, is 8 bigger than 5? Yes, it is. This is true. So again, we copy it over. So in this case, the 8 gets put right there. And then we decrement k yet again. Points there. Now we say, is 3 bigger than 5? No, it's not. So in this case, this is false. We're done with the while loop. And now we're going to put the value 5 into this slot k plus 1. So that's why the 5 here will get written right into this proper spot right there. Okay, so this is an example of inserting into a sorted array. All right, we're going to finish off just by looking at the review questions, and I'm just going to have you maybe pause it on your own right now. And I'll count to 3 and show the answers. 1, 2, 3. And you could read the answers here. Next set of questions. Again, you could pause this. I'll count to 3. 1, 2, 3. There you go. Okay, so by the end of this lesson, you should understand the major differences between ArrayList and array. The major difference is ArrayList can grow bigger, where arrays are fixed in size. The other major difference is that ArrayList have to hold objects. They can never hold primitive data by themselves. Okay, those are the major differences. Okay, that's it, class. I hope you all have a great day. Bye, everybody.